Hello, assalamu alaikum. Can you hear me?
Sir, assalamu alaikum, sir.
Alaikum
Assalamu
salam.
alaikum, sir. Yes, sir.
Yeah, alaikum salam. Can you hear me, right?
Yes, sir.
Okay, good.
Yes, sir.
Okay, so should be fine. So,
Sir, assalamu alaikum.
alaikum salam. Just a minute. Okay, so I'm going to get a snapshot because before the classes start. Okay, another 1 minute to go, and then we're going to start soon. Now, as I have written there, you saw that the attendance is mandatory. It means you have to be careful about it, that every day's class you have to attend, and also marks will be allocated for class performance during the class time. Question will be asked and you have to answer. So if you don't come to the class and you miss the marks, the class performance marks, so that is very important for you to understand. Now, if you look at the screen, you can see, I'll show you the screen at the end. Once we come back to at the end of the class, the time I'll give the marks. So I'll show you that thing. You can understand it later. So during the class time, I'll give the marks that is considered as class performance. Okay, now let's come back to the point. All of you step back. I'm going to take a snapshot. Okay, and then we're going to start the class and see how it goes. Now, every day in the class, actually, I will go through the previous class, and you have to be attentive in the class, very carefully, listen the class, and on the way, I will ask a question, and then based on that, the marks will be given. This is what the way you have to go. So this lecture, what I'm going to give you today, is already uploaded in the BOX, and I assume that you have gone through the lecture video before coming to the class.
Yes, sir.
Yeah, because that lecture, a question will be asking from that lecture video. If you have gone through, then you may answer.
But sir,
Yeah, go ahead.
Some parts of the video was cutted.
Yes,
from
I
19
understand. I understand. I understand. That one will be shown today so that you can understand it as well. I understand. So that means you have gone through the lecture video. This is
Yes,
one of
sir,
the
yes.
thing I need to know actually. That's good. Who are you?
Sir, I am Tehuddin Wara, sir.
So okay, good. Thank you very much, Wara. Yeah, I know that. Just that is the first lecture actually. So you should understand what I mean is those who already actually gone through it can be understood from this. Okay, good. Now I hope that you understand it's important to go through the video lecture before coming to the class. You will understand much better, as well as in the class performance, you can get marks easily. That is another important thing, and that is the main thing. So all of you should be very careful about it, that you need to get the marks. That's why you need to go through the lecture. I hope that should be fine. We can start the class. Now, all of you have to again just confirm me. I think Wara can take the lead. You just confirm me if any problem occurred immediately. Voluntarily let me know. That's
Okay, sir.
not shown. This is cannot be. The first thing is you can tell me the video. Can you see?
Yes, sir.
Yes, sir.
Yes, sir.
Now confirm me the sound. Good morning, everybody. To the second lecture.
Yes, sir.
Okay. Okay, good.
Yes, sir.
Now carry on. Attentively listen, and then asking question answer. You have to answer to the question. If you can, when I ask question, you can answer. you will raise your hand. Don't answer the question for others, then negative marks. You have to answer your question. So everybody very attentively listen to the question, to the class. And if you have any question to ask me, then you raise your hand. And if you see I don't respond, then you can turn on your mic and you can say, sir, I am from the live class. I have a question, like that way. And then I'll
Sir,
stop and then I'll entertain.
I have an issue, sir, with
Yeah.
raising hands, sir. In Zoom, sir, I can't find the raising hand option.
Okay, I'm just going to ask everybody. Can everybody raise your hand?
Yes, sir.
All of
In
you.
the reaction
Yeah,
section.
all
No,
of you.
sir.
All of you raise your
No,
hand
sir.
first. Hey, what do you
Where
mean
is
you
the
don't-
option, sir?
Yeah,
Please
there is a,
check in the reaction.
Yeah.
Reaction.
yeah,
button.
in the reaction
Okay, okay,
tab,
oh.
you just create,
Oh, yes, yes, yes.
click the reaction tab, and then
Thank
you
you.
Oh, yes,
I'm
sir.
asking-
Got it, sir.
you got it, but you do it. Everybody raise your hand. I want to see everybody understand how to do it or not. There's a very important point you raise. Actually, somebody don't know and that's why it's silent. Okay, Abdullah Mubin is okay. Then Shahriar Hossein, can you please raise your hand, Shahriar? You click the reaction
Sir.
button and then,
I already did
oh, you're
that.
done. It's another one. Okay, no problem. So I think you all know, nobody got any confusion about it. Thank you very much. Now you can drop your hand, no problem. You can lower your hand. Okay, that's all. I think this is the way you have to raise your hand if you can answer the question. And if you have any question to ask me also, you have to do the same thing. Anyway, I hope that now you all understand it. Now let's go, and very attentively, you have to listen to the lecture. Okay, let's go and start. Thank you. 201, this is the topic I'm going to discuss today, is a basic electrical circuit parameters. Under this topic, what we are going to see all the basic elements of electrical system. As I told you earlier, there are three basic elements in electrical system, and those are resistor, inductor, and capacitor. Actually, this lecture is a review class of your HSC physics class, what you already studied, the different type of basic what do you call that, parameters in electrical system. So the thing is, I told you until the midterm, we all will deal with the resistor element, the inductor and capacitor, along with the magnetic circuit will be discussed after the midterm. So resistor plays a very important role, and this is a linear device which is used for almost all the circuit theory in DC. So resistor is the thing we are going to start first. So today we are going to talk about this resistor as the system and signal. System and signals, if you go with that, the resistance is a system and the signals are like, you know, you have studied in physics, the current, voltage, power, these are all signals. And resistor, inductor, capacitor, these are all systems. Systems, these are tangible element and those are non-tangible parameters. So signals and systems, this among these we are going to discuss today, these signals, current signal, voltage signal, power. These are the things we are going to talk today, as well as the system resistor we are going to talk today. These are our discussion point, and you see most of the thing you have started in your physics class. So let us go with the next slide. If you go, then in the next slide you can see basically the basic thing we are going to see here, the signal. So electrical signal is first one we can think about current. What is current? It's nothing new to you. You already know that current is nothing but the free electron movement through the conductor. So this electron is flowing through the conductor, and the amount of free electrons flowing through the conductor is a more or less. Based on that, the current will be more or less. So if you see that a conductor is like this, a conductor is something like a box I can write, then what you have started from your physics, that I is the current symbol flowing through the conductor. Maybe we can say this is there's a 5 ampere current is flowing through the conductor. So you all know that the A is the unit for the current, I is the symbol of the current, and 5 is the amount. So we can say 5 ampere current flow, 10 ampere current flow. These are the symbols way to represent for the current, as well as the symbol and the unit are shown in this way. This is all about the current, and this current I and A, all these things you have. Now, the basic understanding of the electrical current, if we go for it, then we can see the basic understanding. If you go, then in the slide, I think you have already gone through that, and this is giving you a clear understanding of the current flow. So if you go with this, a battery is connected with a bulb. So the current is flowing from the positive terminal to the negative terminal. Electron is flowing opposite from negative to positive, but conventional current direction is positive to negative. I think that's all you know. Now, what is this current is nothing but, if I say that what is 1 ampere current, 5 ampere current I've written there, but it's a definition of 1 ampere current is what? 1 ampere current definition is, if this number of electrons drift at a velocity in 1 second, then it is called 1 ampere. That means this number of electrons, 6 into 2.42 into 10 to the power 18 electrons, actually carries the charge, which is 1 coulomb charge. So it means 1 ampere current, actually defined as 1 coulomb charge, flows for 1 second. That is 1 ampere. Now, if I say this is 5 ampere, if I say this is a 5 coulomb charge, not 1 ampere, this is 5 coulomb. If we say that thing is a, okay, 5 coulomb charge, and then it will be 5 ampere, not 1 ampere. The 5 ampere, the 5 coulomb charge per second, 1 ampere. Now, if I say there's a 5 coulomb charge per 2 seconds, not 1 second, then it will not be 5 ampere, it will be 5 by 2.5 ampere, because it's a 5 by 2, 2.5 ampere. Like that way, we can say that if we say that it is defined as a symbol I ampere current, and then you can say this is a coulomb, a Q coulomb charge, QC coulomb charge, 2 seconds, you say T seconds. So we can say that I ampere current is flowing, means Q coulomb charge per T second. Then what will be I? I will be like that, Q by T, because last time we saw 1 ampere is 1 coulomb per 1 second, and then I show you 5 coulomb per 2 second gives you 2.5 ampere. So in general, we can write Q coulomb charge per T second gives you the I ampere. And that is the definition of current. We can write I equal to Q by T. If we follow the same thing, we can write here that nothing but the current definition here we got I equal to Q over T. This is what the current equation we can note. Now, if we go back to the voltage signal next, the voltage signal you are also very much familiar. It is known as electromotive force, EMF, or it is also called potential difference, which is described as the pressure or force that causes the electrons flow in a conductor. So if you apply the pressure between the two terminal, then a flow, like it is, if you can think about this thing, like look at it. If you think like this, I'm taking another color. Okay, if you think like this, a tube like that, so, and this means the water should flow. You can think the water is electron, and P1 P2 is voltage, pressure, potential difference. So this is P1 is a E1 and P2 is a E2. The pressure difference means the voltage difference. If there's voltage difference, the current will flow, electron will flow. As a pressure difference, current is flowing. And if you go with the same direction, if it is less than that, this is P2 is more than P1, like that, then current will flow in this direction. So water will flow in the opposite direction. So which way the pressure is higher, it flow from higher pressure to lower pressure. Like that, in the potential difference also same. The conductor is here, the conductor, the current is flowing through that. If the potential difference E1 and E2, if you think there's connected to a battery is like that, you can imagine. So that potential plus minus, this is plus minus potential difference. If E1 is higher than E2, is a 0 volt, and this is 5 volt battery. So this terminal is 5 volt, this terminal is 0 volt. So the difference is 5 volt here, 5 minus 0, 5 volt here, plus minus 5 volt. We can say this is the voltage difference across the terminal, which is the current will flow from the positive to negative. The current will flow from higher potential to lower potential. That is from the positive 5 to negative 0. So 5 to 0, positive 5 volt to 0, the current will flow. But if you change the polarity of the battery, this one is bigger, this is smaller, this is plus and this is minus, then it will flow in the opposite direction, like that. So like that, we can say that the current difference, potential difference is just the difference of the voltage or potential across the conductor, that causes the current flow. Now, if the, for example, if we see that the pressure is equal, not greater, equal, if pressure is equal, then what will happen? If the pressure is equal, then there will be no water flow. There will be no water flow at all. The whole water will be stagnant. So because of P1 and P2 are equal, the voltages are equal, like that. If you connect two battery, 5 volt battery, one is this way, another one is this way. This is plus 5 volt, this is minus 5 volt. So 5 volt cancel out, 0 volt. So you are getting 5 volt here, you are getting 5 volt here. So the difference is what? 5 minus 5, it is 0 volt. There is no, so no current will flow through that. Okay. Okay. All right. So this is the way we are going to describe the voltage from the pressure of the water. And if you see these things now, yes, it is the thing. It is told here that the electron can flow through the conductor if there is a pressure difference in the between the conductor. I mean, two terminals of the conductor. Okay, now what is the symbol for
Sir.
voltage? Hello, live class. Can you see me?
Yes, sir.
Yes,
Okay,
sir.
I'm just going to the whiteboard and ask you a question, and you have to answer to the question if you can, and you get the marks accordingly. So be ready for that. You just raise your hand if you can answer to the question. If you say, I'm sorry, you say there's a battery here, battery here, connected to a load here. This is the 7 volt battery. This is the 5 volt battery. Okay, so this is point A, this is point B. Now my question here, you have to tell me the current will flow from which direction, A to B or B to A. You raise your hand and I will ask question, only he will answer, remember. Okay, I hope that you can you Hey, can you hear me? Can you
Yes,
see
sir.
the see the
Yes, sir.
screen?
Yes, sir.
I already have
Sir.
raised, sir.
Okay, if you
Yes,
see
sir.
the screen, then you just raise your hand, those who can answer, and then I will ask question and he has to answer the question. But remember, one person should not answer for the others. Okay, this is very careful. Otherwise, negative marks will be given. Okay, now let's come back to the point. Just 1 minute. Somebody returns. I can't hear properly. Who is that? Maria Kavi Kiptia. Are you okay now? Can you hear now, Maria?
Yes, sir. Yes, I can.
Problem. Thank you. Now, I think Ishraq Amin Juardar, you raised your hand. Tell me the current flow direction from A to B or B to A.
Sir, current won't flow at all.
Won't flow at all. Okay. Now, next raised hand, Adri Shankar Das. Adri, what do you think? Is he
My
correct?
answer is same as his.
As
So
he
no
said.
flow will-
Okay, no flow at all. Asif Abdullah Jami. Jami, what is your answer?
Yes, sir. My answer is the same. The current
Same.
will not
Okay.
flow.
Okay. Junaid Karim next.
Yes,
Also
sir.
go the same direction. All goes in the wrong way. That is the right way, right? Okay. And rest of the student. Oh, I'm sorry. I'm sorry.
Sir,
Okay. Okay. Hang on. I'm going from the bottom to the top actually. Okay. Next, Saad Muhammad Tahmid.
Sir,
Shaha
I
Muhammad,
think,
yeah, Shaha Muhammad Tahmid. Yeah. Shaha.
yes, sir. I think, sir, the current will flow from point A to B.
Okay. Point A to B. Okay. Shaha, what is your reason?
Sir, because the potential difference
Hmm.
is greater, that is 7 volt over here from point A.
Mm-hmm. Even that
And-
at point A, the potential is what? 7 volt.
Yes, sir, the
Okay,
battery is
okay,
giving 7 volt.
positive terminal here. Okay, and what is the potential at point B?
Sir, that is less than point A. That is
No,
5 volt.
what is that? Come on, yeah, that's right. You should tell me the value. 5 volt.
Yes.
So you said this is a 7 volt and this is 5 volt. So this
Yes,
is
sir.
positive 7 volt, right? The positive terminal of the 7 volt and this is positive terminal of the 5 volt. So you can say this is 7 volt and that is 5 volt. Now, the potential difference E will be either EA or EB actually. That's okay. I'm not going to learn. So now which one is more potential? Just tell me first.
Sir, A.
Is like the water flow. This
Yes,
is
sir.
P1, this is P2. So you say that P1 is more than P2 like that. So your EA, the voltage potential is more than EB. So your higher potential A and B. So the current flow direction will be from A to B, you said, right?
Yes, sir.
Or B to A.
Mm,
Hey, what happened?
Sir, A to B.
Okay, good. You're not confident, isn't something like that? Okay. Shaha, you are absolutely correct. But are you confused?
No, sir.
So why you should talk all this confidently? Okay, what's your name? Shaha?
Muhammad Tahmid.
Shaha Muhammad Tahmid. Okay, Shaha Muhammad Tahmid will get 0.1. Thank you very much, Shaha. Your answer is correct. Now, all of you get ready now for the next question. Okay.
But
Okay,
sir,
I'm
can
going
I
to, yeah, I'm just going to, hey, all of you drop your hand. How come all of you before the question? Okay, I'm going to draw and then you raise your hand, no problem. Anyway, now you can, if you understand why this is a 7 volt. This is 7 volt. Plus, minus, minus, plus. Now you tell me A and B, which way the current will flow, A to B, B to A. Raise your hand now. All of you, please raise your hand. Which will be the way? Okay, Johara Kamal. What is the answer, Johara?
Sir, the answer is there will be no current flow because there is no potential difference in between these two parts. minus 7 minus 7 is equal to 0 volt.
7 minus 7 equal to 0. So you said that this point is 7 volt and this point also 7 volt, right?
Yes, sir.
So 7 minus 7, 0. So there will be no current flow. So I
In
flow
the
will be 0. There is
Yes, sir.
pressure difference is same. Good. Johra Kamal, you are correct. Now,
Thank you, sir.
now the last question, everybody get ready. First of all, everybody got to lower your hand. Okay, now last question about it, and then we are jumping back to that lecture. Now, let us say that if this is something like this, okay, you know the potential positive, negative, the big plate is positive. That's one. Now you raise your hand. Who can answer this question? So current will flow from A to B or B to A. Okay, raise your hand faster. Okay, now let's go. Johra Kamal, you already answered one, so I should. Tahmid also answered. Now, Safaur Rahman. Safaur Rahman, can you answer?
Yes, sir. So current will flow from B to A as the total
Okay,
potential energy.
okay. Tell
Yeah.
me, you tell me why you answered. What is the potential at point B? And what is the
It's
potential
8,
at point A? 8.
7.
And A is 7. Is it?
Right.
Good.
Yeah.
So this is the answer, because this is all of you can see the answer is like that. This two battery combined together and giving you the 3 and 5 volt. These two battery connected in series. In series, if you torchlight you want to on, you insert the torchlight one after another on the back, and then you on it. You can see that 1.5 volt, 1.5 volt, altogether 3 volt, and then the light is on. And like that, these two are joining together in series, and this is giving total 3 volt and 5 volt together with the same polarity in the direction, one after another, in together 8 volt. At that 8 volt positive terminal is on that side. So you can imagine like this one is just like a 8 volt battery like this. 8 volt battery like that. The positive terminal, negative terminal is 8 volt. It's an equivalent thing like that. It's an equivalent 8 volt battery. So positive terminal gives 8 volt, and the 7 volt terminal gives a plus 7 here. So potential at B is more than A. Your P1 and P2. The P2 is more than P1. So your potential difference will be here 8 minus 7 as a minus is a 1 volt, and that going this way. So the current will flow this way. So current I will be flowing from B to A. But if you say current flow A to B, then it will be minus negative current, you can imagine. Okay, that part I think you will understand it later, no problem. So for the timing, you all understand why the current will flow from B to A, because the potential at B is more than potential. Two batteries combined together. I think you get point 1. What's your name? Can you tell me your name just now? Who answered the question?
Yeah, sir. Safa Rahman.
What's Jafira? No.
Safa or Rahman.
Shafa. Okay, Shafa. Thank you very much. Okay, Safa will get 0.1 for today. I hope that all of you understand how you can get the marks. And I hope that all of you are aware of it now. All of you, please be ready to back to the lecture and try to understand the lecture well. I think all of you are here. How many there? So, okay, good. I think should be fine. And Safa Rahman here, right? Good. Thank you, Safa. Now let's go. Okay. Can you see the screen?
Yes, sir. We can
Okay,
see.
now
Yes,
let's
sir.
go. Voltage. This is the unit for the voltage. And then if based on this, if we can see that this is, as I told you, and it is the flow direction, a current flow direction like this, as you understand. So I can, now everybody can understand this must be the positive, negative, and the potential may be E, and if potential positive here, negative here, because the current is flowing in this direction, we assume higher potential to lower potential. Maybe we can say E equal to let's say 10 volt or 12 volt battery. So if it is a 12-volt battery connected here, positive terminal here, negative terminal, current is flowing from this to that direction. Everybody can understand from this thing, but I'm just going to tell about the voltage definition. What is the definition of voltage? Okay, let's go and have a look of these things. I think you have seen from this. Okay, now look at it. The definition of 1 volt. Last time we saw definition of 1 ampere. This time we are going to see the definition of 1 volt. Now look at it very carefully. Definition of 1 volt means the potential difference of 1 volt or voltage 1 volt means, if you look at the picture here, there are two, what do you call that, charge point, 2 points here. So if I say the voltage difference between this point 1 to point 2 is 1 volt. 1 volt is the voltage difference between these 2 points. What does it mean? 1 volt between these 2 points. Of course, one is a positive, one is negative. In between this, the voltage is 12 volt, 5 volt. What does it mean? So 1 volt means what? From this point to that point. The 1 volt means to move 1 coulomb. 1 volt means to move 1 coulomb charge from this point. Let's say this is A and this is B point. So from A point to B point, to move 1 coulomb charge, if you need to do 1 joule of work done, that is called 1 voltage. That means 1 volt means to do to move 1 coulomb charge from this A point to B point, you need to exert or you need to do 1 joule of work done. This is the meaning of 1 volt. That means 1 volt is giving you the amount of work done, 1 joule, for moving 1 coulomb of charge from point A to B. Now, if you need to move 1 coulomb charge from point A to B, you need 2 joule, not 1 joule, you need 2 joule. Then it will be 2 joule by Siemens, 1 Siemens as a 2 volt. It is not 1 volt, it is 2 volt. Because to move 1 coulomb charge, you need to do 2 joule of work. That's why it is. Okay, so
Here comes the crop part, sir.
hello, can you hear me, Wara?
Yes, sir. Yes,
Can
sir.
you
we
see
can
the
hear you.
screen?
Yes, sir.
Okay, this
It's
is
all
what
right.
your friend told as an interruption. Now you all attentively listen to this. Okay,
Yes,
good.
sir.
Now in this screen, what we understood that if I say that there are 5 joule of, it is A and B point, and it is 5 joule of work is done in order to move not 1 but let's say 2 coulomb of charge. So the voltage will be what? The voltage will be what voltage if you move to if you move a 2 coulomb. Live class student, can you hear me? Live class people?
Yes, sir.
Yes, sir.
Yes,
we
sir.
can hear you.
Yes, sir.
Now you
Yes,
raise
sir,
your
yes, sir.
hand to give me the answer. What will be the voltage over here to move 2 coulomb of charge from A point to B point if 5 joule of work is done to move 2 coulomb of charge? Then what will be the voltage between A to B in this case? Raise your hand. Okay, good. A lot of people raise. Adri Shankar Das, you already answered. You could not answer. Hang on. I think Ababil, you did not answer yet. You can tell me the answer, please. What is the answer?
Sir, it's 2.5 volt.
How you say it?
Sir, because the work done is 5 joule and the charge is 2 coulomb, and if we divide 5 by 2, we will get 1 coulomb.
Right. You are absolutely correct. Now, Ababil, you tell me, if I want to move 5 coulomb of charge, and if I see 5 joule of work is done, then what is the voltage?
Simple, sir. One volt.
So what does it mean? If I say that, if we can say this is in general W joule of work done for Q coulomb of charge to move A to B, so in general, V will be equal to what?
W by work done by the charge.
Coulomb is Q. Charge is what? Q, right? I'm
Yes.
telling you that Q coulomb of charge. Q coulomb of charge means W by
Q.
Q. That is what you can see here, right?
Yes.
Okay, good. Thank you very much. You get 0.1 charge from A to B, and you need 5 joule of work done for this case. Then what will be the voltage we are going to get? I am asking this question to Muhammad Kaushak. No answer, 0 marks. Okay.
W by Q volts.
Good. W by Q volt. That is the equation we have over here. So Kaushik will get 0.25. Okay, no problem. Those who are getting the marks, all of you will stay back at the end of the class, and I will update the marks in the script. Yeah. Now, the same question I'm telling to the live class. Those who got the marks at the end of the class, you have to stay back, and I will update your marks in the result sheet. Thank you very much. Carry on. Oh, any question? Yeah, you raise your hand, Jarif.
To the 5
E is a symbol for voltage. I don't worry about it. Either in some books you can see V, in some books you can see E. So E and V, either symbol or the voltage, you can, some of the volt, 1 volt, 2 volt, 3 volt. This is for volt unit is okay. But E is the symbol which is representing this. Like I is 5 ampere. So E is let's say 5 volt. I'm talking about that thing. So E, you say, some books also say the V as a E, like sort of thing. So don't be confused about these things. I hope that all of you understand that ultimately the equation we are getting for what volt is in terms of joule and Q. This is our main items what we can write here. So what we found here, ultimately I'm writing it here. One equation we got, I equal to what? Q by T, and one equation we got, the voltage equation we got, E equal to W by Q, right? This is what we have concluded, that two signals equation, that is statics equation for current and voltage. So that's what we already got the idea from here. Now let's go back to our next thing, what we were working here. Two signals, voltage and current signal, we have already done. Now we are going to go for the next one, which is the system. As I told you, the system we are going to discuss today is the resistor as a system, and you are very much familiar with the resistor system. In physics you have studied. By definition, you know the resistance is defined, which is what is the behavior, is opposing the current flow. This is the behavior, this is what the resistor's job. Means any substance is having this sort of opposing the current tendency. So if you see a copper iron, it is having a very good, current carrying capacity. But if you see a wood, then you can see I'm talking about the wood. Wood is a very bad conductor. It doesn't have any current carrying capacity because of the electron in the outer shell. You have studied in chemistry. So in copper, yes, 3 electrons. So they are easily, it can move and flow the electron and then give you the current flow through the conductor. That means conductor is having less resistivity, and that's why more current can flow through the copper conductor. But if you go for the wood, it is having no free electrons. That's why the bad conductor, there is no free electron movement. You apply the if you apply, let's say it's a wood, it's a piece of wood, okay, and you apply the battery across this, and what happened if you apply the battery across this, there will be no current flow. Actually, that's what you can see why this is the main, is a bad conductor. But if it is not wood, but if it is a copper wire, copper conductor, and then you can see, oh yes, there are current flow through this, right? This is what because of the wood is having a very high resistance, high resistance, maybe almost infinity ohm, you can say. That's why it does not pass, the current cannot pass through the wood. But the copper is having, it depends on what is the resistance of these things, but it can have whatever the resistance, 2.5 ohm or something like that, very low resistance, and that's why current can flow through the copper. That is what the depends on the material you are using, what is the wood material or copper material of the conductor. Based on that, actually the abstraction of the current flow, actually that's what is the resistance. Now all of you, I hope that understand the resistance part, and all of you should know one more thing, that these resistors are of two types. This is what new to you, two types of resistor. Two types of resistor. Resistor and resistance is a two different thing. Resistor is just name of the element, and resistance is the parameter of it. Is how many ohm, 5 ohm, 10 ohm, like that sort of thing. And the symbolic diagram, I think all of you know that it is something in physics you have studied. This is, let's say, 5 ohm I write here. So R equal to 5 ohm. So R is the symbol and 5 ohm is the unit. So this is the symbol R, and ohm value you have seen. This one is like in the Greek letter ohm. You have seen this ohmic value in physics. You have seen. So you understand the resistance symbol and the the symbol for resistance in writing, and this is a diagram schematic symbol for resistor, and omega, this is the ohm. Ohm is the unit of resistor. You know these things, I don't need to tell you again. But here two type of resistor, this is important for you and new. One is your lumped resistor, and another one is your distributed resistor. This is important to know. Register. So lump register is the register what you can see in the okay, just a minute, let me see, I'm having that one here. Just 1 minute. This, have you seen this type of register where there is a color code there? Any one of you saw this sort of registers with color
Yes,
code?
sir.
Yes,
Yes,
sir.
sir.
You can see in the lab, if you go, you can see this sort of registers with the color code, and based on the, this is a silver or some sort of silver color or golden color, like sort of things. I don't know. So this these are the color code RGB. There's a red, blue, and green. Means red is a 2, blue maybe 5, 4 or something like that, and green is 5, 10 to the power 5, like that. So this is the ohmic value, and according to this you can get it what is the value of this register. And a multimeter you measure, you can see this value is plus minus some percentage, and this is a plus minus 5%. So 5% deviation can be occurred. This is what actually manufacturer to manufacturer depends. So this sort of registers in the lab on the circuit board, you are going to implement your circuit to verify the theory. Let's say Thevenin theorem, superposition theorem. You want to verify this theorem in the lab, then you have to pick this register from the LTO and implement it on the breadboard. Bread in the morning you eat, is that breadboard? You know that project board, whiteboard there. It's okay, good. So on the project board you have to implement the circuit, and that in that circuit, this sort of registers, you have to use the color code register. This called lumped register. I think all of you understand it. Distribute. Anybody have any questions so far? In the audience, you raise your hand. What's wrong?
I didn't understand this thing. I don't know why. Can you elaborate again?
Who is that?
I'm Zohra Kamal.
Yeah, you, and okay, I'm coming back to you. What happened to Adri, Maria? All of you raise your hand. What is the problem?
Sure, I have a different question.
Go ahead. First.
what is the difference between breadboard and a PCB? Like here, I'm
the
very
PCB
confused
and
about this.
breadboard. Breadboard is the project board you can see in the white color, where you can insert your components for test implement a circuit, and you can take it off all the component and put another set of component for experimental basis. But PCB, you have to shoulder the component and dedicate it for a particular application. Once you shoulder on the PCB printed circuit board, then you cannot take it off, and you have to dedicatedly use it. Desoldering can be done and reuse it. That is a separate issue. That is a repairing thing. PCB is not for experimental basis. That is for once decided, then you develop the PCB and implement the circuit. But breadboard is before implementation. You have to test the circuit, whether it's working or not. You understand it?
All right, yes, sir.
Okay, next question, Ishraq. What is that question? Ishraq, a bit faster.
Sir, same as Johara, sir. I didn't quite understand this thing that
Okay, good, no problem. Thank you. Then drop your hand. If you have no question, you lower your hand. Hey, come on, Ishraq, Jordar. If you have no question, yeah, that's right. And Fahad, you have a bit faster. Ababil, raise your hand.
Sir, why it is named lumped resistor?
Oh, because lump is concentrated. Lump, the thing is concentrated, and the opposite thing is what? Distributed. These two sentences you understand.
Yes, sir.
Okay, this concentrated means the big resistance, all you put it into a small part, into a small portion. That's why you can do it, simulate it, or you can use it in the printed circuit board, in your computer circuit board, or anything. The distributed resistor is, I think once you understand the distributed resistor, then automatically you understand why it is lump resistor. Okay, but the word lump is concentrated. That means the big resistance you can concentrate into a small portion or small part. Yeah, that is the lump. Okay, I hope that should be fine. No problem. Any other question now? Then Johara, what is your problem? Hi, come on, a bit faster. Abdullah, what is that?
Sir, RBG. Two,
R is for
4 and 10 to the power 5. Is it the value of RBG?
Yeah, there's a VIP gear. There is a VIP gear, or I'm sorry, BB Roy of Great Britain has a very good wife. If you write like that, then each of the BB Roy means black, brown, like that way. If you go, then first one, black is 0, brown is 1, BB Roy, R is red, red is 2. Like that, there is a system you should know, and you can write in the Google. You can see the color code things. Yeah, you're right. So R is that color, right? R is red 2, and that's why 2. Second one is a B, blue, let's say 5 or 4, whatever that value, and multiply. The third one will be 10 to the power of this 5. 5 is coming from the green. That green is 5. So you have so what is that then? Then you can just find it easily from here. 24 and 50. Then that is the value of the resistor, some mega or something, like whatever. Plus the last one will be the tolerance, plus minus 5%. Yeah, you're right. R is the number, and that number is coming here. B is the number, second number or second band. So they're coming here. You can come to know these things in the lab class. Abdullah, you understand it?
Sir.
Yeah, this is not the lab class, theory class, but I'm giving the flavor. You can understand it. You ask the lab teacher, he or she can explain it in details. But you need to understand here about the lump register. As some of your friends asked me what is lump means. That is important question, because that's what I want to give you the impression. But lab class, you can tell, he can tell you the color code and all these sort of things. Good. Abdullah, you can lower your hand if your question is answered. Now, Johra, what is the problem? You said repeat the thing. What is that? Can you repeat your question, Johra, please?
Sir, I didn't understand the concept, like the manufacturers of the thing. I just couldn't get it. It's a very new thing for me. Can you just make me understand again? Thank you, sir.
All right.
There are a lot of new issues arises. That's right.
What is it? This life is like that, right?
It's like we have never.
Okay, I know that. I know that. Just 1 minute. It is a very simple thing. You know, you should see this thing. Can you see the screen? No. Hey.
No, sir. We cannot.
Sir.
No, sir.
Okay.
It's not visible.
Okay, you'll see soon. Now, can you? Bhara,
Yes, sir.
Yes, sir.
This
Yes,
is
sir.
okay. If you go, a register is a passive two terminal element, ting tang, you can come to know about the data of this thing. In real life, the registers actually look like this thing. You saw this one. 1,000. I think you saw these things in your life, right?
Yes, sir. I have seen it now. I remember.
Yeah, that is the thing what I'm talking about. Yes, if you apply high voltage, burn in the lab and kill yourself. Okay, now these are the things. Register as a color code. If you go with that, I was talking about these things. This is a color code and how to calculate it from here. You can come to know about these things. This is the lab job. Okay, this is the component you are going to use in the lab actually. That's what you come to know. And this type of register we call a lump register. You understand it? And this is in practice. You can see in the PCB and all these things. In electronic circuit, you can see this sort of registers are used. Electronic circuit. And in electrical, you can see the distributed register. The transmission line on the road is carrying 220 volt as a big transformer, and that comes to your home. Can you get me? Do you understand what I'm talking?
Yes, sir. Now it is vivid, sir.
Yeah,
Yes,
that,
sir. Yes,
yeah, that
sir.
is what the okay, we are going to talk about it. Okay, no problem. I know that this one was not in the, that's why you are in. Okay, now you can go ahead with me and try to get my point. Distributed register, in contrast, this is something like a conductor. A long conductor is like this, and there is resistance per unit. Let's say for 1 meter from here to here is 1 meter length. For 1 meter, this is, let's say, copper wire. So copper wire, where you can see in the transmission line, if you go outside Dhaka, you go outside, you look at outside through your window, you can see the transmission line next to on the road, right? There's a copper wire you can see there from one transformer to another transformer. This is a contribution that's distributed. That wire are copper wire. So this copper wire, if you take 1 meter, so 1 meter might have 0.01 ohm. Just I'm telling you. Then 2 meter will be just double because it is uniformly distributed in the, I'm talking the copper wire on the transmission line. I'm talking, this is one of the example of distributed register. So if I say from Dhaka to Ashuganj, because Ashuganj power plant, they are producing the power and that power is coming to Dhaka. It's a long transmission line. So the long transmission line got a lot of register, and that's why a lot of transmission loss is there. We'll see these things later. But what is the amount of register? Those PDB guy, REB guy, these guys can easily calculate it and then tell what is the resistance from Ghorashal to Dhaka, this conductor, copper conductor, and that according to that they can calculate how much loss is there and this, that, all these things. So that register calculations are coming under the distributed register. So distributed registers calculation can be done through this formula. I think you have already done it. Maybe you saw this in physics, this sort of calculations. So R equal to this, where your register is proportional to the length, register is proportional to, inversely proportional to the area. So length and area, is a copper conductor is a circular copper conductor. The length is here L, and the cross section area is A. I think you can remember in physics you have studied. So the more the length is, the more the resistance is. The smaller the conductor radius is, the area is less, then the resistance is more. It's a opposite to the other one. So joint variation, according to the law of joint variation, you have to apply both of them together. It will be L by A. And if you bring the proportionality constant rho, which is the resistivity, I think you have studied in physics, then rho is coming here and it is giving L by A. So the equation is coming rho equal to L by A. So these things is calculated through this R equal to rho by L by A. So A is uniform, the circular area is uniform throughout the whole conductor from Ghorashal to Dhaka, and if it is copper conductor got some resistivity and is fixed. So this resistivity and these things are fixed. Like I'm talking about this rho and A is fixed, so only R is depending on the value of L. The more the length, the more the register. Like that way you can calculate from here. So these things actually for copper wire, for another type, different copper wire are there in the market. Let's say you get a job in Energy Pack. Energy Pack is doing what? Hey, do you have any idea? Energy Pack is produce what? Is producing milk and deliver in the whole country. Energy Pack. Are they producing milk from the cow?
No, sir.
Yes, good. The main job is there. The main job is when Bangladesh, a long time long ago, when we were studying in Buet, at that time, America. Hey, you have in Dhaka, right? Yeah, those who are from Dhaka, you know that, and the Nagpur is the big market in Bangladesh, and that actually import the things from overseas and distribute all over the country. So you go to Nagpur and ask the guy, hey, give me the wire. They will ask you what wire you want. I want to make a transformer, give me the wire. They cannot give you anything unless you give some specification. And the American guys, they have done this job 1,000 years ago, and they made it standard. We Bangladeshi ducks are just learning the thing, and so they have made the standard already. So we have nothing to do but to accept their standard. And according to their standard, you have to talk to the shopkeeper. You please give me this thing. What thing? You look at it. Can you see the screen? Yeah, yeah. This is the standard gauge for those sort of wire all over the world. Actually, AWG, American wire gauge. So if you tell the shopkeeper in Nagpur, hey, give me 24 AWG. You know, I'm talking about this gut. Give me 24 AWG, they can straight away give you that wire and tell you how long you want. So for your primary winding of the transformer, you need this much, another one, that you can easily buy it from them. But if you tell them, give me the thin wire, give me these wire, copper wire, they cannot give you unless you tell them this number, 24. They know this number very well because it's standardized. So based on how, as an engineer, your job is to find out which gauge is required for your transformer. That depends on this data sheet, and this is standard from China they are getting. So this is at different temperature, the value of resistance per 1,000 feet. So this is the resistance. That means this resistance per 1,000 feet. So if you go for 14 is this 2. So from your calculation, if you find that you need 2.54 per 1,000 feet, your resistance is this, then you have to go to the market and buy the number 14 one. Then you can tell them, give me number 14 AWG gauge wire for my transformer. They will give you how much you need. You can buy it from them. So this is the standard AWG gauge. Actually, you need to get what should be the wire you need. You want to find. Then this table you have to follow as an engineer. So this is what one of the important thing for your distributed registers when you get a job in the electrical side, electronic side, depends on. This GAT is for electronic side, that is for electrical side, especially we can say in that way. Now that's all about your registers part, and you can do the calculation for these things easily from the equation as we have seen. So it is nothing new, everybody know it. So we are not going to that much. And these three relationships, now Mr. Ohm, Simon George Ohm, actually he actually in his long ago, 2018. Plus, I'm telling you, this is Ohm's law. We are going to go. Everybody should very attentively listen, because this is the basic of electrical engineer. What is Ohm's law and how it comes? All of you listen carefully. 1900 something, 21,000 years ago, actually he was playing with these three items. What he was playing with the battery and current, and he was seeing that if you change different battery through a conductor, then different currents are flowing. He took these things as a game. Actually, what happened? So he got a data sheet. He make a data sheet E and I, and what happened? He put a 5-volt battery. He put a 10-volt battery. He put a 15-volt battery. He put a 25-volt battery, and every time he see the current is flowing through the conductor as a different days. He put a 0.1, there's a 5-volt one, then the 10-volt one, then the 15, then the 25. Like that way, you see that voltage 5, 10, 15, 25. Like that voltage, different voltage he is applying, and he is getting the things at different current he is getting, and that current, the corresponding current, and then draw the points. And after drawing the points, they join the point. They got a point like this. Oh, he's amazing. okay, what's this? It's a good relationship we get. And it's a very much linear relationship he got. Then he had started working on it. And he said, what is the equation? Hey, equation, any children should know that x, y, if the equation is coming, y equal to what? Can you remember? Y equal to what?
MX.
MX. Every children should know that. MX. So y is mx, so E should be proportional. He understand E is proportional to I, like y equal to mx. So E should be equal to some M should be bring, and M is nothing but your R, and that's it. What he found, oh my God, I got it, and he got a Nobel Prize, or he got a PhD. That 1,000 years ago I'm talking about. So he built up the relationship of this conductor, and the relationship is coming as equal to IR. And you know that is the Ohm's law, and according to his name he got the equation, and that is the birth of electrical electronics engineering, EEE, and that's going on step based on that. Lots of theory and law comes up. But that's a basic I'm talking about. Each and every duck in the classroom should know this. What is Ohm's law? In the interview board, you can't answer. Kick out from the law. So careful about it. This is very, very basic and important. This is the starting of the Tripoli. So the Ohm's law, he found that E equal to IR, and that is what I'm going to show you here, and you can see in this sheet. And then the Ohm's law comes in that way, E equal to IR, or you can manipulate it, I equal to E by R, or equal to R equal to E by, whatever way you want, you can just manipulate it, and you can get this equation, Ohm's law. After getting this Ohm's law, we have relating this, actually, I'm sorry, we have related this three things: voltage, current, and resistors, right? And now I am asking a question here. All of you be ready to answer to the question. Everybody should know that, but I'm just, okay, one guy was asking me this question. I'm telling him the question. You all go back to that. I'm going to draw it again. Okay, here, this is what I have drawn as a 3 ampere. This is 5 ampere. Okay, this is the question I'm going to tell you. Okay, so if I ask you the same question here, what is that thing? Is a 7 volt, 3 volt, 5 volt? Okay, I told you these things. This is plus minus, plus minus, plus minus. Okay, so if this is the resistors, we can say that the resistance is 5 ohm resistor. Okay, can any, I think I want to know what is the current flow through the circuit, and it's last time we have seen the current flow.
Sir, what is the third volt?
What is the, I'm sorry, can you repeat?
7, 3, and what is the third?
5 volt.
Okay, sir.
7 volt, 3 volt, 5 volt, and this is a 5 ohm resistor. Question is, what is the current flow through the 5 ohm resistor? We don't worry about the direction. Just later on we can see the direction. But I'm talking about what's the amount of current flow. Raise your hand, bit faster. Okay, okay, you raise your hand. I'll ask the question to a new person first. Those who did not get any marks yet. Abdullah Al Mubin, have you answered any question?
Sir, is it 1 ampere?
Come on, you tell me the answer. Have you answered any question yet?
No, sir. I haven't
that's
answered
good.
any
That's
question.
the first question you have to answer me. Okay, then you tell me the answer. What is that?
So the answer is 1 ampere.
1 ampere. How you say 1 ampere? What is the voltage across 5
sir,
volt?
voltage
5 ohm.
It is 5 volt.
5
And
volt. What is
the
that? What is
resistance
listen, come on. What is the voltage at this point, and what is the voltage at this point? Tell me what is the voltage here.
Sir, 10 volt.
Okay, and what is the voltage here?
5 volt.
Okay, minus 10, minus 5. If you say
volt.
is all right. Minus 10, minus 5 is okay. And the difference is
5 volt.
5 volt. So 5 volt is the voltage difference across this. So what will be the current then?
So then the current is 5 divided by 5.
Yes, 5 ohm divided by 5 volt.
5.
Is it?
Yes, sir.
5 ohm divided by 5 volt.
No, sir.
No,
Right.
sir.
What is 5 volt by 5 ohm or 5 ohm by 5
Yes, sir.
volt?
5 volt by 5 ohm.
Sir, 5
Hey,
volt by 5 ohm, sir.
Yeah, I'm telling you. Hey,
Sir,
listen,
E
come on.
by, E over
please listen.
Yes, sir.
Anybody try to help others he will get negative marks. Remember, next time I'm just telling you, first time you don't know. I ask Abdullah, let Abdullah answer. He cannot answer, then come to you and you can answer in that time. But don't try to help him. Okay, so in the class, I'll not give marks to anybody in that case. Anyway, now today I'm giving Abdullah 0.1, but be careful about it. Don't answer for others. Thank you very much, Abdullah. You are right. Now let's go answer. So A and B, current flow was, you told me, from B to A. And what is that current flow? That is what my question here. B to A means this is plus and this is minus. Otherwise, it cannot be from B to A. Okay, the current flow, I should be in that direction. My question here, what is that current flow? Can I ask one is here, current flow through this, and the direction of the current flow is like this. But if I say, if I say that the Jarif only.
Yes. Okay.
Okay, now I'm asking Jarif. Potential, this is AB, VAB means this is plus and minus.
Yes, yes.
What is
sir.
that?
Yes, 10.
What AB? This is plus minus electrical power you can consider, and the unit of ohm 100-watt bulb. So if I should be positive current, that's what
Positive.
this is the thing. I don't want to explain these things. It's not important. Now jump to power. Let's go.
Yes.
Different. Yeah, current flow will be negative, positive. It depends on your assumption of this thing. I hope that you got the point, and
Yes, sir.
slowly you will be clear as well. I'm not giving you any point because you could not answer the question perfectly. So Jarif will not get any marks. I hope that you'll be ready for next question. You can go for it. Now, this is what we can get the idea, and slowly we'll get the idea more. Now, after going through this Ohm's law, our last topic today we are going through is the power. The power thing is becoming a big factor and a very important thing. If you look at the power, by definition, you all know that you have a bulb at home, 100-watt bulb. So if I say what is the power of the bulb is 100 watt, that means was 100 P equal to 100 watt. What is the unit for the power? You already know, and power P is defined as a P as a symbol. And what is power? You, by definition, you all know from physics that power is the rate of work done, right? In general, electrical power, which are considering for the motor power, generator power, heat, light power, like sort of things. But in basic definition of power from physics, you have studied is power is the rate of at which the work is done, or the rate at which the heat is generated, like sort of electrical power you can consider. And the unit of power you also studied, it is watt and represented by W, and P is the symbol to represent the power. So this is all about the power definition. And from the power definition, if you come as in physics, P, hey, all of you can see this line. A bit faster. Some of you raise hand. Any question or just?
Sir, actually, Safaur Rahman is waiting outside. He had some issues with his internet by the time.
Okay, ask him. Ask him. I have last class. I have told if you have any emergency, what to do?
To call you back.
Right. He has to pay money for that. Is it? That's why he's not calling. Just tell him to give a call. Need to know what is happening, and then I'll allow him to come in. Okay. Don't waste.
Okay.
Just tell him in that way. Another duck. Ababil, why you raise your hand? Any question or just for nothing? Okay, always don't, yeah, if you don't just raise, lower your hand. Very important point, power. All of you concentrate. You have to answer question as well. Power is the rate of what? Work done. What does it mean? Jarif, can you tell me? Then I'll give you 0.25 marks. What is the equation?
Yes, sir.
Yeah, power equal to what?
Sir, work done per unit time.
Yeah, power per unit time means symbolically what is work done? In physics, you
Sir, W by T.
Very good. W by T. Excellent. All of you look at it carefully. It's not finished yet. Now, okay. Jarif, if
Yes,
I
sir.
say that W, if you divide it by Q, okay,
Yes, sir.
Q, and if you multiply with another Q here, over here, Q, and then you go back to the T. So T is W by T as it is because Q cancel out, right?
Yes, sir.
Okay, we can write it like this. live class people, you raise your hand if you can give me the answer to the question, what is W by Q, what is Q by T? Raise your hand. Okay, Asus, what do you mean by Asus? Who is this duck? Can you talk to me, Asus?
I forgot to change my name.
Oh no, you change it and then you give me the answer first. Okay, you just change it and then I'll ask you the question. Meanwhile, I am coming down. Johra answered the question. Ishraq already answered. Saiful also answered. Okay. Okay, Asus, you change it and then I'll ask you a question. Bit faster. I'm giving you.
I change it.
Yeah, I'm giving you 5 minutes time.
Sir, I changed it. Hello.
So my name is fine. Can I answer?
Sir, I changed my name.
I think Sari is in call now.
Yeah.
Hello. Yeah, Asus. Who are you?
Yes, sir.
Mohammed Saqib, is it?
Yes, sir.
Okay, so you did the annotation, right?
No,
Why
sir.
you change your name then?
Sir, I open from my.
Okay, it's all right, no problem. I have the opening thing now. Anybody do it, his name will come immediately. I'll catch him. Remember. Okay, everybody, please write your name. Hey, Maria Kiptia, what happened to you? You didn't write your ID number. Everybody, Abdullah bin dumb. Everybody, write your ID number. I'll drop you out from the class. Please, faster. Asif Abdullah Jami. Please, everybody. Rafayat Islam Rajib. Write your ID number. Shahriyar Hussein. Write your ID number. Junaid Radin. Write your ID number. Please, I'm just telling you, all of you, requesting you, write your ID number. Otherwise, I'll not give you the attendance. And if you do not know how to write, you tell me, I'll write it for you. Abdullah Al Mubin, what happened to you? Or you are not in the class, sleeping? Or
Sir, I'm in the class, sir.
Okay, then why don't you write it? Don't know how to write. You ask your
Sir,
friend,
I
he can
actually
tell you.
don't know, sir.
Okay, just this is not good. You should you ask your friend
Sir,
and
I'm
then
trying,
tell
sir.
Okay, tell me what is your ID?
Sir, 203211049.
Okay, in the class at the beginning, you have to tell me if you have any problem like that. Okay. Now, Muhammad, who is the guy? Muhammad Saqib, please go.
Yes, sir.
Can you please answer the question? What will W by Q equal to what?
Yeah, it is, sir, volt, V.
Volt, V or E. Good. And what is Q by T?
It is I, current.
I, current. So volt into current. That is E into I. Good. Excellent. Thank you very much. Go ahead. So if this is the scenario, Jarif, can you tell me, 2.5 marks is not so easy, man. You have to collect it easy. So can you, from your dream, can you see the dream and tell me what is W by Q?
Sir, this is voltage. Watt per unit charge.
I think all of you can understand, I hope, that how it's out, right?
Yes, sir.
Okay, we can write it like this. So E voltage from here, right? And what is this?
Sir, this is current.
Absolutely good.
Charge per
This
unit.
is current, as we have seen. That's what all of you can remember. We have found it over here. Over here. Where is that? Here we go. So this is I, this is E, we found already. Now that E and I, we are writing W by Q is E and W. Okay, I think Jarif should, you Jarif, right?
Yes, sir.
Okay, Jarif should get 0.25. Now you are able to get it. Good. Okay, that's what the power definition we can have from here. I think all of you can understand, I hope, that how the power is going to become P equal to E into I. This is power definition. Basic definition comes function of I and E. And again, you can write, if you substitute the Ohm's law, E equal to IR, then it will be what? E equal to IR, it will be I square R. Do you understand it, all of you?
Yes, sir. Yes, sir.
Some of you. Okay, I'm just going to show it and cut it. And Ohm's law means this gives you what? I into I square R. So that is the thing I told you, that I square R in terms of E by R and then E square by R. I hope that all of you understand it. I don't need to explain. So this is what another, I'm sorry, this is another way we can also put the value E square by R. So you have another pattern of these things, and which is the function of E and R. So whatever parameters given to you, if you are given the I and R, you can find E and I. These two you multiply, simply you can get the power calculation. If I square R, I and R given, you can straight away calculate this power. If E and R given, you can straight away use this equation, and so all are valid equation. If we go, hey, all of you be ready. I'm going to use that thing, got the thing here, 5 things here like this. Okay, this is your plus minus, this is your 10 volt, and this is your 5 ohm resistor here. Now if we say then current, hey, what is the current coming through that? One of your friends said, what is that? Any duck?
So it's 2 ampere.
It is 2 ampere. Anybody can
2
tell
ampere.
me this. Yeah,
Yes.
10 by 5 is equal to 2 ampere, right?
Yes, sir.
Okay, now let's go. One boy drop down without calling me. You'll be in trouble. Farhan will give 2.25. You can answer all the question. Get ready. Tell me what is the first answer here. What will be the answer here? Tell me. P equal to what? The live class. Raise your hand. Okay, first question. Junaid Karim, have you answered so far?
No, sir.
Okay, you tell me what will be this value here. Bit faster. You
I
saw my
didn't even-
cursor.
Okay.
I and E.
I and E is gonna be. Wait a second, sir.
What? Sorry.
Just a minute.
Okay. You know, if from the circuit you see what is I and what is E, then you can multiply. You tell me the answer. You don't need to wait.
Is it going to be 20?
How you got I equal to what? E equal to what?
I is equal to 2 ampere and E is equal to IR.
Oh no, come
So-
on. E equal to what? In the circuit given here already, the voltage.
Oh, E is equal to 10.
So what is that?
So that is 2 into 10 is
20. So very simple, right?
Yeah.
What is your name?
Junaid Karim.
Junaid Karim. Okay. So next, Junaid 0.1. Okay, no problem. Next, Farhan Noor Shorob. Have you answered any questions, Farhan?
No, sir.
Okay, for the next one, what is the answer for the next one? First,
Sir, 20 watt.
20. How you got?
Sir, ampere is the
Come on,
current
that
is,
I equal to what? R equal to what? Multiply. This one you have to explain.
yes, sir. I equal to 2, E
Hmm.
square 4, and R equal to 5 ohm.
So 4 into
This
5?
is 20.
4
20,
into 5
20
is
watt.
21. 20 watt. Good. Thank you very much. So it's very
Thank you, sir.
simple. I think you understand it. I'm just going to show. But I into E if you use this equation. What is that?
Sir, 20 watts.
20 watts. How you say I equal to what?
I equals to 2 amps. We have found out from that
Yeah,
current
and E.
volts. So 10 squares and
Okay, now okay.
amps.
Two. Okay, now let's come back to the next one. Farhan, you got the answer. Fardin, have you answered any?
No, sir. You
Okay,
didn't
you
ask
tell me
this.
what is the last one?
So the answer is 20. Here,
How?
is okay, sir. Here E is 10 volt. So then 10 volt and R is sir 5 ohm.
Okay, so 10 means what?
10 square means 10
10
square
square
by
equal to
5.
what?
Sir, 100 by sir 5.
5 equal to what? 40.
Equal to sir 20.
20. So we can see the first one is 20, second one is 20, third one is 20. So any equation you use, all are giving the same answer. So all the equations are validated. Good. All of you can now have a look of this thing, what I told you. And it's coming. Okay, good. Farhan, you should get 0.25. Thank you very much for this answer to this question. And the last thing I'm going to give you the thing, just show you the thing. You just go ahead with this problem things. Actually, can you see volt lead acid battery and an automobile headlight? If the battery deliver a total energy of 460.8 watt hour over an 8-hour discharge period, then how much power is delivered to the headlight and what is the current flowing through the bulb, assuming this is remain constant, the battery voltage. Okay, now all of you can hear me. I hope that one of you friends, or the thing is cut from the scenario in lecture 1, video lecture 1. Can you see this video lecture that what is uploaded already in the video? Yeah, I'm just going to show you. Just you can see this thing now. And yes, you said yes, sir. From here, can you see the problem? Hey, come on.
Yes, sir.
Okay. So from here onward, you can just have a look.
This is the point.
So this is what so from here onward, now you are on track. So earlier part is cut and it started here. In between, what happened today, I have already shown you. Is it okay?
Yes, sir.
Okay, so fine. Okay, and rest of the part you can very easily can go ahead how to solve this problem and all these things. I think it should not be any problem in that case. But now you understand what I'm talking.
Yes, sir. Yes, sir.
All right. I hope that if any question, any problem, beginning of the class, 15 minutes earlier, next class, if anybody got any question regarding this, please join the class 15 minutes earlier. I will open the classroom 15 minutes earlier next class so that you can have your question with me. And student tutor, one student tutor contact number, everything is given there. I'll update both student tutor on the BUX and I'll send an email also very soon by this week. And you can communicate the student tutor also about the problem. If you have anything, let's say this problem, you cannot get it, then you can also talk to the student tutor. And 15 minutes earlier, you come to the class, next class, so that we can discuss if you have any problem to this to understand. I hope from now on, everything is clear. Now, I think because the time's up and we are not going to continue the class, and I hope that you can do it by yourself from here onward. That's it. Thank you very much. Those who got marks, you please listen to me and stay back. And rest of you can leave the classroom if you have no other question to ask me. I'm reading the name: Shaha Muhammad Tahmid, Johra Kamal, Safa, Ababil, Abdullah Sakib, Junaid, Farhan, Fardin. If any of the name I missed, please you remind me. I'm going to show you the screen and all
Sir,
of you.
I answered the question.
Yeah, please, I'm telling you, please remind me at the end. Just wait. Don't leave the room. Can you see the screen? Hey, can you?
Yes, sir.
Yes, sir.
Yes, sir.
Yes, sir.
Every day, I'm going to give the marks, and then you have to tell me from the left-hand side serial number. Your name you can see, and you tell me the serial number, your name. Okay, first I'm talking about Shaha Muhammad Tahmid. Where is serial number? I'm scrolling first. You can see your serial number. All of you can see your serial number, and there are some 201 and
26.
Yeah, okay, good. I think you have seen already 26,
20.
right? Saha Muhammad. Okay, I'm giving you 0.1. Now this is sorry, just a minute. Okay, 26 is here. What's wrong?
The here protected view is enabled. You have to disable it first.
Anyway,
So
okay.
click on protected
Okay,
view
no, it's all right, no
settings.
problem. 26, right? Hey, who's the gut? Safa or what? Shaha Muhammad Tahmid. Shaha Muhammad Tahmid is this one,
Yes,
right?
sir, 26.
Okay, 0.1. Like this, I'll give the marks. For today date, you can see on the top, it is 15/6/21. So it's all right. Now, next
Sir,
person.
20.
So yeah, Shaha, you can leave the room if you don't have any other question. Okay,
Sir,
Johra,
sir.
if you have
of
question at the
those-
end, please at the
Okay,
end.
okay.
Just wait. Johra,
20, sir.
20. Good. Thank you very much for helping this. Okay, thank you very much. And next, Safa. Safa, can you
Sir,
tell me?
2 from EC01.
Oh, it's 2. Okay, which one? 2.
Yep.
Oh, this one. Okay. So you are getting good. So you can leave the room. Thank you very much. Now, Ababil.
So it's 16.
16. Good. 16. Okay, you can leave the room if you don't question. Abdullah. This is
Sir,
Abdullah Jami. Who Abdullah?
Yes, sir.
There are too many
Sir, my
Abdullah.
serial is sir 14.
Oh, you answered the question, right? Okay.
Yes, sir.
Thank you very much, Abdullah Al Jami. And Abdullah Sakib, who is that? What's the serial? Abdullah Sakib, are you here? Abdullah Sakib?
I think his name is Muhammad Sakib.
Oh, Muhammad Sakib. Who is the serial
Sir,
number? Can you help me?
I 29.
Are you Abdullah Sakib? Where
No,
is
sir,
20?
Muhammad Sakib.
But where is 29? It's not there.
It's 12.
Sir, 12.
Are you okay? This one. Oh, Muhammad Sakib. I'm sorry, not Abdullah Sakib. Okay, I'm sorry. Thank you very much. It's my mistake. Thank you, Abdullah. Muhammad Sakib, I am giving you 0.1. Thank you very much. You can leave if you don't have a question. Now,
Okay,
Junaid,
sir.
please, Junaid, your name?
25, sir.
25. Thank you very much. 20.
So I have a question.
Yeah, just a
I'll
minute.
stay
Let me
after the
finish and
question.
then we'll discuss.
Yes.
And next, Junaid Farhan.
19.
Good, actually. This is today first time, and that's why I'm just going to show everybody, and you can come to know about it. Fardin.
Sir, actually, sir, the screen has been freezed in my case.
Oh, you cannot see. You cannot see.
Yes, sir. My,
Okay, what is your
screen has
ID number? Tell me if I.
Sir, my ID number is 203210. Means, sir,
I'm sorry. What is it? 20?
The 20, 32, 10, 25.
Okay, good. You get 0.1. Thank you very much. I have given your marks. Why your screen is freezed?
Sir,
So I think the screen's
because-
frozen for
My
everyone.
screen is for me, it's the same also.
Yes, sir, for
Oh,
everyone.
I'm sorry. You cannot see.
Yes, sir. The updates that you are making, we cannot see, sir.
Okay, now can you see, all of you?
Sir, sir, reshare
Can you
it.
please
please, sir.
scroll it down?
Oh,
sir?
okay. I'm resharing. Okay, no problem. I got a point. What's your?
Reshare it.
Oh,
Yes, sir.
that is
That's
the
the
problem
problem,
happened. Okay, yeah, yep,
Yes, sir.
yep. I got the point. All right. Oh, yes, sir. There is a problem from the Zoom actually because of the file. I have saved it. Actually, that is the main thing they have making trouble. Okay, just a minute. I'm going to save the file first. Okay, now, hello, can you hear me?
Yes, sir. Yes, sir. I can.
Okay, I think the Zoom is freezing the, what do you call this? Stop sharing.
Share.
Yeah, that's right. I think all of you saw the sharing thing. I have already given the marks for everybody. Only one person was telling me, right? I did not give you the marks. I didn't call your name.
Sir,
Who is that?
Sir, I couldn't get the chance to respond, sir.
Okay, what's your name?
Sir, Wara, sir.
Wara.
Yes.
Okay, Wara got. Oh, you did not get the chance to answer question.
No, sir. No, sir.
Okay,
I raised hand almost.
No, it's all
4
right.
or 5
It's
times.
okay. You should raise it faster than others.
Sir,
And next class, listen, next class on what we'll do, I'll ask individually, not like this. Those who did not get
Okay, sir.
marks.
Ask me 2 questions, then, sir.
No. Listen what I'm talking about. Today, those who got marks, it will be recorded. So next class, I'll ask not get marks. So you don't need to worry about it. You understand me?
Sir.
Next class, I'll ask
Yes,
you
sir.
question and you have to answer and then you get the marks. No problem. I think
Sir.
you will come to know about it. Don't worry. Okay, I think it's still having problem because wait for the
Sir,
response.
I have a
What's the
question,
problem?
sir.
Yeah, go ahead.
Sir, won't you give the marks to me as I have already answered a question?
Yeah, that's what I'm asking. I'm looking for you. What's your name?
Sir, Abdullah Mubin.
That's right. Good.
23, sir.
Yeah,
serial
yeah.
number.
That's Abdullah Al Mubin. Okay, I'm giving it to you. 23. You sure?
Yes, sir.
Just
23.
let me check. Yeah, 23 Abdullah. Good. Okay.
Thank you, sir.
Yeah, I have given your marks and you can leave now, but I cannot show you because of some problem. Next class, you can see. I have given the marks, all are recorded, so you can easily see the thing. Next class, no problem. Okay. Hello.
Yes, sir.
Okay, no problem.
Okay, sir.
Now marks is done. You can leave the classroom if you have no other question. If anybody got any question, you can start now. Tell me what is the problem.
Sir, last day you asked us to wait until the class ends for those who wants to change the G Suite email ID.
Yes, sir. I didn't. Okay, I didn't do it right.
I don't know, sir. Actually, my
No,
power
today
cut off.
I think in your
That's
class
why I
I
had to
didn't
leave
do it.
early.
Yeah, I didn't do it in your class. So what you do? You
I also emailed you, sir.
No, not on email. I'm going to wait for a while. Just